In this lecture, we are going to discuss about high-level language and the difference between compiler and interpreter. For high-level language, we have got a higher amount of abstraction from the hardware. Now, as we remember that for machine-level language and for assembly-level language, the abstraction was not that high. For machine-level language, the abstraction was near to zero because it was very close to the hardware. And for assembly-level language, a little amount of abstraction was there, and that was the only reason we used assembler as a translator. But here, for high-level language, it is so special that now we have got a very higher amount of abstraction from the hardware. So now we have got some higher advantage than that of the low-level language here. Now, what kind of advantage is that? Let's understand. So we have got some very specialized translators like compilers and interpreters to translate the high-level language to the machine-level language. Now, why these translators are so special? Because it is providing a very higher abstraction to the high-level language. Due to this higher amount of abstraction, now we have got a great amount of portability. So now it is highly portable. That means it is machine independent. If we want to run any particular code to any particular system without any kind of problem, we can run it. But first, we need to translate the source code with the help of compilers or interpreters. Then we can just easily run it on that system. So the basic advantage and the benefit that we are getting here is the readability, maintainability, and the portability. Now, for the readability, as we all know that the high-level language is human readable. That means now we have got a human readable programming language which is very understandable by the human, and that is the only reason the maintainability is also higher. So if any kind of complex code to be written, then we can easily just maintain it due to the highly structured language, and the portability is also there due to the higher abstraction and due to the sophisticated translators like compilers and interpreters. So let's understand how this conversion actually happening. Now, as you can see, this high-level language is sent as input to the compiler and interpreter, and they are just providing output as machine-level language like zeros and ones. Now, these are the binaries. So this compiler and interpreter is working as translator here. Now, there are two types of high-level language: compiled language and interpreted language. Let's understand their functionalities. Now, for compiled language, we are just converting the source code to the machine level language with the help of compiler, which is a translator. Now, how this is just converting this source code to the machine level language is a very sophisticated process. Let's understand how. Suppose a source code is there and now we are feeding it to the compiler. Now, what compiler actually does here, it just compiles the whole source code from line number 1 to the end line. As you can see that here, suppose the entire program consists of 8 lines. So the compiler is going to compile from line number 1 to line number 8. The entire program, it is going to be compiled by the compiler. Now, during the entire program compilation process, if it finds error, we'll just throw the error to us, and now we have to debug and recompile the program. So that means we have to rectify the program. After the rectification is done, again we are going to feed the source code to the compiler, and now again the compiler is going to compile it from line number 1 to the end line. And if it finds zero error throughout the entire program, it will create object code or executable code. Now, this object code and executable code is the binaries or is the machine level language, and we can just easily run or execute this machine level language, which is understandable by the processor. Now, for interpreted language, the source code is interpreted and executed line by line. Let's understand how. Suppose this is the source code and we are feeding it to the interpreter. Now, what interpreter will do? It will interpret and execute the code line by line. Suppose the line number 1, it will interpret it and execute it. Then again, the line number 2 will be interpreted and executed. Then line number 3 will be interpreted and executed. Now, let's talk about line number 4. As we can see that we have got some error here. So this error will be thrown to us. So what about line number 5 and line number 6? This line number 5 and line number 6 won't be executed. So what we need to do now, we need to rectify this code. So now we are debugging or rectifying the code, and after the rectification, we are again going to feed it to the interpreter. So now we have got the rectified source code, and now we are feeding it to the interpreter. So now, as you can see that all the lines are being interpreted and executed without any problem. So now it is quite clear for compiler, as entire program was being compiled and then we were getting some executable executables, but here for interpreter, each and every line is interpreted and executed. So it is not necessary that the entire program will be interpreted first. It is just going to interpret and execute one line at a time. Now let's understand the differences between the compiler and the interpreter. So for compiler, it's just translating the entire source code into the machine code before the execution process happening. But for interpreter, the translation and execution is happening simultaneously line by line. Now for compiler, after the compilation of the entire program, it produces object code and executable code. There are differences between this object code and executable code. Within the object code, it is just unlinked machine code. So the linking process hasn't been happened here. But any kind of linking process after being done to the object code, we get executable code. Now you may find it bit confusing right now at the present moment, but when we will discuss the core functionalities of the C programming, then it will be very clear to you. Now for interpreter, no separate executable file is being generated because the interpretation is happening on the fly and the execution is happening simultaneously line by line. Now for compiler, we have got the faster execution. Now why you are getting the faster execution here? Because here the source code has already been compiled and converted to the machine code. So we are just executing the machine code here. So that is the only reason we have got the faster execution. But here, as each line is being interpreted and executed, so due to this simultaneous process, the slower execution is there. In case of compiler, slower debugging process is there because to find any kind of error within the program, the entire source code will be compiled first. Hence, the slower debugging process. But for interpreter, we have got some faster editing, testing and debugging phase. So as soon as the interpreter finds any kind of error, it will just stop the interpretation process and it will throw you that error. It is the only reason, suppose you have got some kind of error at line number 3, it will just give you the information about the error straight away without interpreting the entire program. Now for compiler, the source code is only platform independent. But when generating the executable code after the compilation process, that is platform dependent. So that is the only reason whenever we are going to run any source code to any platform, first we have to recompile that particular source code in the target system, then we can just run it on that system. For interpreter, no such kind of recompilation process is necessary. It just can interpret the source code and execute it on the fly.